Okay guys, so this is the first video that we'll be doing. Now this is based on the topic of speed, displacement, velocity and acceleration. You will find this on the Teams page. So what you do, go to Teams, go to Files, go to Physics, and it should be there, okay? So this is where we were going to start if lockdown hadn't happened, but here we are, okay? So the procedure that is expected of you, okay, is I'm going to go through this. Now the video will be in two parts, okay, because the video will be about 20 minutes to 30 minutes, but of course that's me talking, okay? So what you'll have to do throughout this video is pause the video and take down the notes that I tell you to take down, okay? So you will have to pause it as you go, all right? Take down what I tell you to take down because it's kind of important, okay? And make sure it's nice and neat, okay? So the first thing there, guys, is your heading. Your heading is speed, displacement, velocity, and acceleration. So you can take that down as your heading, okay? So this is your heading here, okay? Speed, displacement, velocity, and acceleration. This is your heading, okay? So start by taking that down. If you want, again, pause the video, take that down, all right? Then, of course, as always, your learning intentions is the next thing, okay? So this is important. You need to take this down. Now, this will be in two videos. So the video will be in two parts, part one and part two. So you'll get part one today, and then I'll put up part two then on the next class, okay? So your learning intentions, that's your next subheading. Again, guys, pause the video, take these down, okay? You don't have to try and rush them, okay, as I talk, okay? So the first one, we will calculate speed, displacement, and time, okay? So what I mean by that is that these three are linked, okay? Your speed is related to your displacement and time. Your time is related to your speed and your displacement, and your displacement is related to your speed and your time. And what we're going to discover is how are they all related, okay? And then from that, how you can calculate each. So if you know two of the three, you can calculate the third one, okay? You'll be able to get the velocity of an object. You'll be able to understand what velocity is, why velocity is different to speed, okay? Now, that is all we'll be doing today. We'll be doing those two, okay? But take down all of them. Take down all five, okay, for your notes, just for consistency. The second class, so that's today's class. That is video one. In video two, we can calculate the acceleration of an object. If that's what you're going to be doing, you're going to be looking at the difference between speed, velocity, and acceleration. How do you get acceleration? You will learn how to draw a velocity time graph, speed time graphs. Okay, so I'll go through exactly the kind of the rules that are there for the graphs, okay? But generally, you draw them the same as you draw any other graph, okay? And then the last one, you will be expected to do this yourselves. You're expected to go away and design an experiment on how you would conduct an experiment to test the speed and the acceleration of an object. So you will have to, that'll be an assignment at the end of the second one, okay? You'll be expected to go away and figure out, I think I have two, let me check my notes there. I think I have two different experiments. Yeah, so I have two experiments that you will be expected to go away and figure out, how do I test this? Okay? So pause the video, take them down. Okay, so take down all 5 points. Okay, your keywords. Again, take down the keywords as well. Okay, so our keywords are new words. Some of these words, actually all of these words, you've definitely heard before, but you've probably never actually thought of them in a scientific context. Okay, so that's the difference with these keywords. You've probably heard of them, but you never actually thought about them. Okay, so a lot of times we hear these scientific words and we never really think about them. For example, speed, distance, time, velocity, displacement, acceleration. Okay, speed. What exactly does speed mean? Okay, that's the thing. What does speed actually mean? What does distance mean? What does time mean? What does velocity mean? Okay, that's what all these different things mean. We've all heard of it. The speed of the car. Oh, he accelerated. The distance to travel. What time is it? But we never thought about it in a scientific, physical context, and that's all that is. Okay, so take down. So pause the video again. So your first subheading was learning intentions. The next subheading is keywords. Okay, and take down the keywords. And again, when you're revising this topic, okay, you will go to learning intentions. And do you understand? Now, for physics is slightly different, but would you be able to, I'll give you lots of examples later, notes and stuff, to calculate speed, displacement, time? Do you understand what they are? What's their relationship? Do you understand what velocity is? Do you know how to get the acceleration of an object? Do you understand how to do time graphs? And do you understand the experiments? If you can do all of those, move to your keywords. Can you explain the 6 of these? If you can explain them, then you're fine. Okay, you pretty much are okay for this topic. Okay, so that's the reason for learning intentions and keywords. If you can do the 2 of those, you pretty much know this. Okay, right. So we move on to our next topic. Okay, so our next subheading there, guys, is simply take down the subheading speed, and I'll tell you what to take down here. So the first one is speed. Okay. Now, the first things first. If someone is traveling faster than you, what does this really mean? Okay? So a lot of times we don't think about it that if you're running a race and we say, oh, that person is faster. Person A is faster than person B. Okay? Well, what does that actually mean? What does it mean to be faster? Okay? And everyone will go, oh, it means they go quicker. And that doesn't make sense. Well, explain to me. Well, if I don't understand the word speed, what does speed mean? Okay? You have to try and explain it. Okay? So what we try and say in physics, it's the idea of covering a distance in a certain amount of time. Okay? So for example, if person A is faster than person B, okay, that means if they had to run 100 meters, person A would cover the 100 meters in a lower time than person B. Okay? So if you're faster, you can cover a distance. Okay? So for example, look at the car speedometers, 60 kilometers per hour. What does that mean? That means that you travel 60 kilometers every hour. Okay? 60 kilometers per hour is faster than 50 kilometers per hour. Why? Well, it is because 60 kilometers per hour means that it takes them an hour to travel 60 kilometers. So in the time, it covers 60 kilometers of distance. 50 kilometers per hour means in the hour, it only covers 50 kilometers difference. So the first car covers 10 kilometers more. So therefore, its speed was faster. Okay? So speed is the distance traveled in the given time. And that's where this equation here comes about. So in physics, okay, so generally in physics, guys, oftentimes you can give your answers as the mathematical equations, okay, because they mean the same thing, the exact same thing. So there you go. That's all I want you to take down from this point here, okay, is the last bit there, speed, okay. Speed is the distance traveled, okay, in the time given. Now there's a little bit of a mistake there. That shouldn't be S, that should be M. Just make a note there. Okay, so the distance traveled in the time given. Okay, so the distance traveled in the time given. Distance is in meters and time is in seconds. Now what you can do as well in your own time, if you wish, you have access to the PowerPoints. If you wish, pause this video and click that little link. So let me take this out here. So if you want, click this link, okay, on the PowerPoint, and it'll bring you to another YouTube video going through speed, okay? By all means, pause this video, click that, watch that video, and then come back here. Or if you wish, finish this video, and then in your own time, go back and watch that video. But do watch those videos. These are kind of summary videos, kind of interesting videos that can help you out, okay? All right, so staying on the topic, this is still the heading of speed. So it's all under speed. I want you to draw in this triangle, okay? Now, it's also referred to as Dad's silly triangle, okay? The reason being is the first letter of each of this word, you see? D for distance, S for speed, and T for time. Dad's silly triangle, DST. You see? D, S, and T. Okay? So take down that heading and draw in your triangle. Draw in this triangle here. This is vitally important. Okay? So you can pause the video while you're drawing that in. Okay? Distance, speed, by time. Okay? And the question here, how many equations can we make from this? Okay? So how many equations can we make from this? So if you want, try and figure it out there. I'll give you a second before I start doing them, okay? Well, let's look at it first. So I'm gonna write them, and then of course I'm gonna delete them as I go, so you'll have to pause the video as we do this because I'm a little bit caught in space here. All right, so the first one is simple, okay? Distance, DIS. What would distance be? Okay, so how you use this type of triangle thing here, okay, is you cover the object that you have. So we have distance. So what I do here is I mark distance out of my triangle. And what am I left with? Speed multiplied by time. So speed by time. You see? So that's the first equation. Distance equals speed by time. That's my first equation there. Distance equals speed by time. Okay? So that's the first. That's one. So let's do another one. Let's do speed. So what would speed be? Okay, so again, in your triangle, get rid of what we have. We have speed, so we knock that out. That's what we're looking for. So what do we have? We have distance divided by time. So it's, I'll write it differently. So distance divided by time. Okay, So distance over time. So speed is your distance divided by time. That's why in your car, I don't know if you've ever noticed it, it'll be kilometers / hour. What that means, it's kilometers over hour. You see? Distance over time. That's why it's kilometers per hour. That's why it's done that way. Kilometers per hour is kilometers, which is distance, over hours, which is time. You see? So that's our speed. So that's two equations we've gotten from this triangle. Okay? So the last one then to get is what is time? And again, in your triangle, cover what we know. And what are we left with? Distance and speed. So basically time is distance divided by speed. You see? And that's it. 3. We can get 3 equations from this. Okay? So we have distance is speed multiplied by time. Speed is distance divided by time. And time is distance divided by speed. And that's it. You have your triangle. You cover what you know. And then you fill it in. So there are 3 equations. Okay? So there are 3 equations. You should take down. You can rewind the video back. Take down the 3 equations. Okay? What are the 3 equations? All right? Now, don't worry too much about trying to learn them off. Okay? It'll come to you in time with practice. But also, it's more important to remember the DST triangle, Dad's Silly Triangle. If you remember that, you'll figure the equations out every single time. Okay? All right. So, the key here, now this is not so much, now this is because I'm a physics teacher, I kind of push this a little bit, just because it's very important for doing Leaving Cert Physics to get used to this idea. But generally, it's not that important, okay? Generally, you will get away with leaving it. However, the SI units all have to link up, okay? So you need to be able to convert, distance to meters. Okay, so you need to be able to convert distance to meters, time to seconds. Okay, you need to know how to do that because sometimes they'll give you the distance in kilometers and the time in seconds and ask you for meters and seconds. Okay, so just be aware that'll be a very higher order, right? So that's just the idea, guys. Sometimes they can ask higher order questions and that's when they do it. Okay, so all I want you to take down here from this, okay, really, is take down the heading. Don't forget to convert the units. Okay. And the SI unit, because these 2 bits are not so much in a new course, but I'll go through a few examples now in a second. So the SI unit of speed is meters per second, kilometers per second, or kilometers per hour. Okay, so there you go. Meters per second, meters/seconds, or meters per second, or kilometers per hour. Okay. Now usually they'll keep it in meters per second, but I'll go through some conversions now in the next slide here. Okay, so keep the heading. So the heading, guys, is don't forget to convert your units, take down the SI unit and the kilometers per hour, and now we'll do it here. Okay, so we'll do a few extra ones. All right, so the first extra one we'll do is kilometers to meters. Okay, so kilometers to meters. All right, so km, the K stands for kilo. So kilogram, kilometers. Okay, the K means kilo. That's what the K means. That's what kg is, km. Okay, and what that means is by 1,000. You see? So kilo means 1,000. All right. So when you see kilometers, that means 1,000 meters. When you see kilograms, it means 1,000 grams. Kilo means 1,000. Okay, so we'll do an example then. 50 kilometers, you multiply 50 by 1,000, which gives you 50,000 meters. That's how you convert kilometers to meters. You multiply by 1,000. Okay, that's it. So kilometers to meters, you just simply multiply your number by 1,000. Done. Very easy. Yeah? Okay. Now, the next one I want to show you is for converting. So there's 2 different things that we're going to do here. So the first one is going to be minutes to seconds. Okay, so time is a bit different. Okay, So basically, if I have 5 minutes and I want you to tell me how many seconds there are, okay? Well, how many minutes are in each second? So, or sorry, how many seconds in each minute? 60 seconds for every, sorry there, every minute. So there's 60 seconds for every minute, okay? 60 seconds for every minute. All right? So for every minute there has to be 60 seconds. All right? So therefore, how do we convert minutes to seconds? That'd be 5 multiplied by, okay, hold on a minute there. No, something went wrong there on the tablet. So, all right. 5 times 60. Okay? 5 times 60. That's all you do. And that gives us 300 seconds. Okay? So 5 minutes is 300 seconds. How did I do it? For every minute, there's 60 seconds. You just multiply the time by 60. That's it. Very easy, yes? Okay? So very easy. You just multiply every minute by 60. Okay? Now, the trickier part is as follows. Now, tricky part, right? So 2 hours, okay? All right, how do we convert that? Okay, so, or better yet, actually, I'll give you a heading first, sorry. So hours to seconds. So now we're going to go hours to seconds. So we got to convert our hours to seconds, okay? Well, how do we do that? Okay, so there's 2 things. For every hour, there are 60 minutes. So for every hour, there's 60 minutes, okay? So every hour has 60 minutes, okay? And how many minutes in each, or how many seconds in each minute? And then 60 seconds for each minute. Take all this down, guys. You should be taking all this down, okay? It's good revision for you, all right? So for every hour, there are 60 minutes. There are 60 seconds for each minute, okay? All right? So take all that down, because I need to rub it out now to get space for myself, all right? So therefore, 2 hours, okay? So I got to convert 2 hours. All right, to seconds. How do I do it? So that becomes, right, 2 bracket. Actually, no, we'll get rid of the bracket because I don't think you're doing that in maths. You're doing just a multiplication sign. So, wait, I don't know what's going on there. There we go. So 2 multiplied by, so what you do is you put down how many hours you have. So this is the hours here, multiplied by the number of minutes in each hour. So there's 60 minutes in every hour. So 2 by 60. So that's our minutes. So that's our hour. That's our minutes. And now I want our seconds. So how many seconds in each minute? Well, there's 60. And that's my seconds. You see? Do you understand that? So what did I do? I just basically said how many hours? 2 multiplied by the number of minutes in each hour, 60, multiplied by the number of seconds in each minute, 60. So therefore, that gives us 7,200 seconds. So for 2 hours, that's 7,200 seconds. And that's it, okay? So hopefully you took all that down. If you didn't, quickly go back through the video, pause it as you do and take it down, okay? That's how you convert meters, kilometers to meters and minutes to seconds and hours to seconds, okay? Now, hopefully you don't get anything like that, but it's important to know it, okay? But generally, it's good to know just for maths as well, maths reasons. Okay. So let me see now. Okay, we're about halfway. Okay, so we're halfway through this class. All right. So what we'll do, what I want you to do is take down each of these and attempt them. Okay. So starting with the first one, so I'll number them 1, 2, entry. Okay, so question 1, calculate the speed of a car that travels 500 meters in a time of 20 seconds. Question 2, calculate the time it takes a truck to travel 890 meters at a speed of 10 meters per second. And question 3, if a cyclist is traveling at 10 meters per second, how far would they have traveled in 30 minutes? Okay, so there are 3 different kind of questions that you could get asked based on this topic. Okay, so pause the video, take down the 3 questions and have a go and answer them and see. And then check back here when you think that you've got it done to see how you got on. Okay, so I'm just going to move on then there quick. So question 1. All right, so let's look at the question 1 then first. So question 1 says, calculate the speed of a car that travels 500 meters. So what is speed? Let's go back to our density triangle. We have speed, that's what we're trying to find. So what are we left with? We're left with distance over time. Okay, so that's our equation, distance over time. So let's go back here now. Okay, so we were asked to calculate the speed. So speed equals distance divided by time. Always state your equation in physics. Always state your equation. Okay? If you skip that step, you'll probably make a mistake. All right? That's why you state it. And what do we have? We're told that our time is 20 seconds and our distance is 500 meters. So what's that going to mean? That means our speed is going to be 500 divided by 20. So the zeros will cancel. So we're left with 50 divided by 2, which is 25 meters per second. And there you go. That's the answer to the first one. Okay, so question 1, you're traveling at 25 meters per second. Okay? All right. So now we look at question 2. So I'll clear this out again. Pause the video, guys. Check your work. You don't have to keep up with me. All right? So question 2. Right, so question 2 is this one. So calculate the time. So go to your dad's silly triangle. Time. We take time out. What are we left with? Distance and speed. So distance divided by speed here. So let's see the way here now. I haven't even read the rest of the question. I just said, what am I looking for? Time. And get it. Okay? So straight away you can put down your, so time equals distance divided by speed. Okay? And what are we told as well? So it takes the truck, the time it takes the truck to travel 890 meters, that's our distance, at a speed of 10 meters per second. So what's our equation? Our equation is going to be, so time equals 890 divided by 10. And of course the zeros will cancel there. So it's going to take how long? It's going to take 89 seconds. There you go. Okay, nice and easy. All right, so now we'll do the last one, the third one there. And then we'll move on to the next topic. Okay, so the last one then is question 3. If a cyclist is traveling at 10 meters per second, how far is, that's distance of course. Okay, so that's distance. So we're looking for distance here. So if we look at this, we have this. So what's our equation? Speed multiplied by time. You see? That's all it is. You go to your triangle and you get it from there. So it's going to be speed multiplied by time. And if we look at it here, time is 30 minutes. And so there's a problem here now. We have to do one thing first. Okay? So we have a speed. Speed is 10. Okay? So we know that that's 10, but time is 30 minutes. So we have to convert that to seconds first. How do we know we have to convert that to seconds? Can anyone tell me? It's because of here. See here? The speed says it's meters per second, not meters per minute. So because that's seconds, we have to convert everything to seconds. You see? That's how you tell. All right? So how do we convert 30 minutes? What did we do earlier? 30 by 60. That's all. You see, multiplied by 60. 60 seconds for every minute. That gives us 1,800 seconds. So that becomes 10 by 1800, which gives us 1800 meters. 18,000 meters. And there you go. Okay, so that's it. There are the three different ways you can do the equations, the three different ways the equation can be written out. Okay, right. Oh, excellent. Okay, and let me rub that out there. So displacement. So let me see. I have 1, 2, 3, 4, 5, 6. So there's 6 slides to go. You don't have much to take down actually. It's mostly just me explaining. So your next heading is displacement. Okay, and I want you to take down 2 things here. I want you to take down the definition here in bold. Displacement is the distance in a given direction. Okay, so it's different to distance. Okay, so distance is just a regular distance, all right? Whereas displacement is distance in a given direction. Okay, so this distance in a given direction. That's the key here. And I should have kept an eye on the time to see how long this video is recording. Anyway, we'll move on. Okay, so I'll try. So after today, I'll try and keep an eye on the time and try and make sure none of the videos go over half an hour. I think half an hour is long enough for a video, but I didn't actually keep track of time this time. Now, what I want you to do is take down the definition, and I also want you to draw in this. This is important because it shows you the difference between the two. The blue line here between A and B, that is your displacement. Okay, straight line as the crow flies. The orange line with the arrows here is your distance. Okay, all right. So basically, the distance from A to B is not the same as displacement. They're 2 different things. Okay, so you can pause the video, take down the definition, and draw in there the distance and displacement. Okay, they're 2 different things. Your displacement is a straight line from where you started to where you finished, where your distance is the path traveled. Okay, so for example, when you got up this morning, you got out of bed and you walked into wherever you are. So you walked to the kitchen. Okay, this morning, when you got to the kitchen, from your bed, a straight line from there to the kitchen is your displacement, but your distance is everywhere you walked to get to the kitchen. Okay, so there's a difference. Okay, that's the way to think of it. All right, so that's why it's important to take down this and the diagram. And here's a few more examples. You see, the first one here, the distance and displacement are the same because they're basically covering the same distance. The second one, distance is longer because they're going around corners, whereas displacement is 100 meters. Okay, and the big one here to really kind of hammer it home is the last one. You don't need to take these down, guys. Okay, is their displacement is simply 80 meters, but their distance was they went 60 meters north, 80 meters west, and then 60 meters again. Okay, so they went 60, 80, 60. All right, so in other words, their distance here was 200 meters. So they walked 200 meters, but they're only 80 meters from their displacement. Okay, so that's why they're different. Again, as before, you can pause the video here and watch the YouTube link here, or you can just watch it later and come back to it in your own time. Okay, but I do advise watching them. They're kind of entertaining. Right. And that's kind of just a recap of that. Okay, we can say that the distances you want to ground you've covered, while displacement is the distance in a given direction. Okay, all right. So that's just kind of a recap, and actually you don't need to take that down. Once you have this and the diagram, this kind of just explains it again. All right. Okay, so you don't need to take that down. That's okay. Now to your next heading, velocity. Okay, so velocity and speed are not the same. They're similar though, and the maths is kind of the same. All right, the maths is very similar as well. Okay. But your velocity, you need to take down now. Take down the first point here and underline the bit in bold. That's important. Okay. Velocity is different to speed, and that depends on displacement, not distance. Okay. So it's different to speed because it's the displacement, not distance. So speed is distance covered in the time taken. Velocity is displacement covered in time taken. All right. And then take down the following. This is your equation. Now, unlike speed, they generally won't be asking you to do the other variations, okay? Generally, it's going to be what's the velocity, they give you the displacement, they give you the time. It's very rare they do the others, okay? Now, they can, okay? They can, don't by all means. I have 4 questions coming up for you to do. And in the 4 questions, the last one gives you displacement and then time, okay? So you have to be able to rearrange this equation. What would the SI unit be? So again, take down this. So take down 3 things, the definition to start, but underline the displacement is not distance, okay? Take down the equation, velocity is change in displacement divided by time taken, and then take down the SI unit, okay? Right. Again, pause the video, guys. You don't have to keep up with me here. So this class is almost finished. We've just 2 more slides. All right, so velocity. We have a picture here, don't take it down, but just I want you to think about it for a second. So we have an Aer Lingus plane and a British Airways. So the Aer Lingus plane is going from Dublin to London, okay? And the British Airways is going London to Dublin. So the Aer Lingus plane is saying, I'm going at the same speed as you. So they're traveling at the same speed. But then British Airways says, yes, but I'm going at a different velocity to you, right? So they're traveling the same distance. They're both going from London to Dublin. They're both traveling at the same speed, but they have a different velocity. How is that? How can that be? How can they have a different velocity? Well, it all comes down to their displacement, you see. All right? So displacement is distance in a given direction, you see? Distance in a given direction. So Aer Lingus is going Dublin to London. British Airways is going London to Dublin. Therefore, their displacement is different, you see? Because velocity is change in displacement divided by time. So therefore, their displacements are different. So because their displacements are different, their velocities are different. So that's why speed and velocity are not the same. Okay? Now, the last thing we'll have you do, this is it. This will be the end of the class, the end of the video for today. Okay? Is the following. Take down, so we have 4 questions here. So take these down. Question 1, question 2, question 3, question 4. So write these into your copies, guys. You write them down in your notes copies because they're very important examples. Okay? Calculate the velocity of a car that travels 1,000 meters east in 20 seconds. Question 2, calculate the velocity of a cyclist traveling 2,000 meters east in 3 minutes. Okay? Remember now, convert to seconds. Calculate the displacement of a train if its velocity is 50 meters per second in a time of 30 seconds. Calculate how long it would take a truck traveling at a velocity of 40 meters per second to cover a distance of 3,000 meters. Okay? So, pause the video there, write them down and work them out. I'm going to go have a go at them here and now. Okay? So, can I get rid of the box? There we go, much better. Okay. So, question 1. All right, so I'm going to pop back here. All right. Now, actually, if you go to your notes, you see your equation here. Velocity is change in displacement divided by time. Now, to save us the time of writing it all out, you can use the symbols. So, velocity is V. So, that's going to be V. Now, displacement, distance is D, but displacement is actually S. Okay, so that's going to be a little bit confusing. But displacement, the symbol for displacement is S. And time is, of course, T. So V is S over T. That's what these symbols mean. And they're the symbols I'm going to use now. So S is for displacement, T is for time. You don't have to use the symbols. I'm just using it because I'm low on space down below. Okay? So question 1. V equals S over T. Velocity equals displacement over time. Okay? So my first question is, car travels 1,000 meters east in 20 seconds. Okay? So, which is which? Well, my displacement is 1,000 meters east in a time of 20 seconds. So then do the maths. All right. So what does this mean? Well, another way to rewrite this is 1,000 divided by 20. That's what's happening there. So if a number below the line is you're just dividing, that's all. Okay. So 0 cancels out 0. So it's 100 divided by 2, which gives you 50 meters per second east. So we're still traveling east. 50 meters per second east. Okay, that's the first question. Done and dusted. Okay, so now we look at question 2. So I'm going to keep the equation up there because it's going to be actually I'm going to rub it up and move it up actually. V equals S over T. Just give me space. So question 2. So question 1 is done. I'm going to take that out. So question 2, calculate the velocity of a cyclist traveling 2,000 meters east in 3 minutes. Okay, so my time is 3 minutes. I got to convert that to seconds. So how do we do that? We multiply it by 60. So that gives us 180 seconds. So 3 6s are 18 plus 10. You see? 180. So therefore, that's what the 3 dots means. It just means therefore, V equals, what was the distance? 2,000 meters. 2,000 over 180, okay, which is 2,000 divided by 180. So the zeros will cancel there, okay, so you're left with 200 divided by 18. which should give us here a very weird number. Oh, hit the wrong button. So that gives us 11.11 meters per second. So our velocity is 11.11 meters per second. Okay, that's question 2. So now we look at question 3. So accidentally rubbed out a bit of my equation, but that's fine. So question 3. So we can take out question 2 there. That's done. So question 3. Calculate the displacement this time of a train. All right, so first things first, calculate displacement. Displacement is S. So if velocity equals displacement divided by time, how do we get rid of the t? You bring it up here and you multiply it across. So therefore, question 3, displacement equals velocity multiplied by time. It's very similar to Dad's silly triangle, if you imagine it, okay? Because you have velocity, displacement, and time, okay? So it works on the same principle, really, all right? Now, so let's go back to the question. The question said the velocity is 50 and the time is 30. So S equals 50 multiplied by 30. And that just becomes calculator work, okay? Well, you can do it in your head as well. 3 times 5 is 15, okay? And then you have a 0 here and a 0 here. So what does that mean? It means you have to put in the 2 zeros. So 1,500 meters. And that should be a 0, not a weird looking 6. Okay, 1,500 meters. All right, and now the last question and the end of this class is calculate how long it would take a truck traveling with a velocity. So time. So let's go back to this. So let's rearrange this now. So this is more awkward. Here we want time to be on its own. So you got to bring time above the line, which means you got to divide across by v also. So therefore time is displacement divided by velocity. Again, go back to Dad's silly triangle. Here, you see, time is distance over speed. So time would also be velocity divided by displacement. Okay, now let's go back to our question. A velocity of 40 meters per second to cover a distance of 3,000 meters. So my displacement is 3,000 meters and my velocity was 40. And the 4 cancels there. So 300 divided by 4 gives us 75. 75 seconds. Okay, that's the end of part 1. That's all you had to do for today. If you have any questions, you can leave it in the comments section below or put it up on the Teams page. Okay, I'll then put part 2 up for the next class. Okay.